Okay, in algebra you learned how to find a composition of two functions, f of x and g of x, symbolically as f of g of x, or f, little circle, g of x. When I was in high school, we called that fog, and we called the one over here, we called that goff. And these two things, these two pieces, the fog and the goff, will rarely be the same thing. If they are the same thing, the functions are inverses of each other. So here in this first example, you see an example of f of g of x, and out next to it I'm going to write the g of f of x. So pretty straightforward stuff. Again, f of g of x and g of f of x will rarely be the same thing. So if you're looking at f of x as sine x and g of x as x cubed, you would replace this x with x cubed. And in the next one, you would replace this x with cosine. So, this next big plane functions and composite functions. I've never had an issue with that. If you have questions, I shouldn't say it that way. I have not had an issue with that yet with anybody. That doesn't mean that somebody's not going to be confused by it. If you are confused by the difference between plane functions and composite functions, please let me know. Okay, so I don't know what this last year stuff is about. I never noticed that before. The chain rule can be written this way. The chain rule says that if y equals u to the n, then y prime equals n times u to the n minus 1 du dx. So you see some familiar things here. You see that we've got the power, bring it out front, subtract 1 from the power, but then suddenly you have, what is that? I'm going to explain very quickly. So all that's saying right there, that du dx, it's saying that here you've got something, some sort of inner function u, and you're taking the derivative of that inner function with respect to x. Now what you're going to start seeing later in the course, in fact not very long from now, is that sometimes you're going to be taking the derivative of y, and that's why that's important. You've got to remember that when you're just looking at, up until now, everything's been pretty straightforward, and we've just been looking at functions that look more or less like that right there, and we're just differentiating with respect to x. Oh my gosh, I hope I'm making sense to you. If I'm not making sense to you, would you please ask me in class? Okay, so du dx means you are multiplying the derivative by the inside quantity. Our calculus book, which, by the way, you do have, it is in PDF form, and I have linked it in a secret place, and you need to remind me to tell you where that is in class on Wednesday. So here we have the same thing as in the previous box. These two things are the same thing, just written differently. So the derivative of the outer function, keep the inner function, times the derivative of the inner function. It's actually kind of fun. Oh, we already did that part. I'm not going to rewrite it there. We're going to find the derivative, and do not leave negative exponents or complex fractions in your answers. Okay, so all I've done right here is I have taken the derivative of the outer function. take the power down, subtract 1 from the power. Once you've done that, you need to take the derivative of the inner function, take the power down, subtract 1 from the power, and voila, you are done. Next one, take the power down, subtract 1 from the power. Once you've done that, you're going to take the derivative of the inner function, which would leave you with 4x cubed. And you also need to remember to read the directions. And it says that you should not have any negative exponents or complex fractions in your answers. So let's fix it quickly. And we see that 2, oh gosh, that looks like a prime, doesn't it? 2 times 4 is 8. We keep the x cubed on the top. The 3 stays on the bottom, and we turn our negative exponent into a denominator, and we're done. Next bit, we need to find the derivative of this one, and the easiest way to do that is going to be to change it into a product. So when we change it into the product, we take the power down, subtract 1 from the power. Once we've done that, we have only taken the derivative of the outer function, and we still need to take the derivative of the inner function, and the derivative of the inner function would be 2. Now we need to move things around so we have no negative exponents. So 14 times 2 will give us 28, and we're left with 2x minus 3 cubed on the bottom. Okay. Boom. I think I'm on the right page. Yep, okay. So we can use trig formulas. We can use trig formulas the way they are written on your formula sheet. And we can do pretty complex. I think I'm missing some stuff. Give me a sec. I'm missing the whole problem, you guys. I don't know where it is. Oh, there it is. It's the top. Okay. Sorry. Okay, so we're gonna change this into a product rule and then take the derivative. So I change it into the product, and once I've done that, I see not only do we have a product rule, but we also have a chain rule. So the derivative of the first would be 5, and the derivative of the second, we would have to use chain rule. Oh, wrong kind of parentheses. Bring down your power, subtract 1 from your power, and take the derivative of the inner function. And the derivative of the inner function would simply be 2x. Now, if you are taking a test, you stop right there. But we aren't taking a test. And we simplify, and we have something that you should be able to figure out. 5 times 2 is 10. X times x is x squared. The negative came from the negative 1/3. The 3 came from the negative 1/3 as well. I changed the negative 4/3 into something to the 4th with a cube root on it. Okay. I hope you can make sense of that. I feel like I'm going really fast, but I keep forgetting you can push pause. So now we look at our trig formulas, and we can find the derivative using the chain rule. So in the case of cosine of 3x, we know that the derivative of cosine x is negative sine, and the sine of 3x is 3. So this is just negative 3 sine of 3x. And the sine of 5x squared, well, that would give us, I'm going to do this the slow way, cosine of 5x squared, and then we need to take the derivative of the inner function, and I'm just using square brackets so that I can keep track of things, not because there's anything special going on there. And then when we simplify that, we get 10x, or when we write it in a pretty way, I'm not really simplifying, am I? 10 cosine 5x squared. And our last one, the derivative of cosecant is negative cosecant of the stuff times cotangent of the stuff. But we need to take the derivative of the inner function, which would give us 35x to the fourth. And when we simplify that, we get negative 35x to the fourth, all times cosecant of 7x to the fifth, cotangent 7x to the fifth. Okay, the first thing to remember here, oh, I wrote cotangent. What? I gotta fix that. Okay. The first thing you gotta remember is to copy your problem right. The second thing you gotta remember is that this power right here can actually, right there, can actually be rewritten in this form. Whoa, it's not doing what I want it to do. There. That people have a hard time getting their brains wrapped around because they're so used to using your calculators that you haven't had to think this through very much. Right here on the left is how we write it on paper. Right here on the right is how we write it in our calculators. And a lot of people haven't put those two pieces together quite yet. Bring down your power, subtract 1 from your power. Take the derivative of the once you've taken the derivative of the outer function, which would be something to the fourth, then you take the derivative of the inner function. Once you've done that, you simplify, and you bring that cubed down inside because that is the way we write it by hand. Okay, I'm going to try to go through this one a little bit more slowly. So take down your power, subtract 1 from your power, take down your power, subtract 1 from your power, then take the derivative of the inner function. But wait, there's more. You also need to take the derivative of secant. So, actually, I don't like the way this worked out. Okay, take 1 from your power. Okay, bring down your power, subtract 1 from your power. Then we're going to take the derivative of the secant. And the derivative of the secant is secant tangent. Once you've taken the derivative of the secant, you're going to take the derivative of the innermost function. So if you really allow yourself to think about this, this is kind of a Russian doll situation where you've got this outer function of the squared, then you've got this inner function of secant, and then you've got this hyper inner function of 4x cubed plus 5. And yes, I know I'm drawing over everything. So this is your innermost function. This is the derivative of your middle function. And this, the 2, and the power of the original secant, that's the derivative of your outer function. Boop, 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 boop. Okay. Now, this simplifies quite nicely. And there we go. Our derivative is more complicated than our original function. Okay, next problem. Next problem, we're going to find h prime of x. Similar to the problem you had on your test. But not the same thing because we didn't have chain rule on the test. Okay. If you look at what I just did, I figured out what h prime of x was before I figured out what h prime of 3 is. I very rarely have a student who can find h prime of 3 without really explicitly stating this first. Do that first. Do it in that abstract, symbolic form before you go any further. So now you can look at it and just replace x with 3. So h prime of 3 would be f prime of g of 3 times g prime of 3, and g of 3 is 4, so now we're going to have to find f prime of 4. And these are going to be on almost every single test from here on out. Some people get super confused, and if I don't keep on it for the rest of the year, you're going to forget when you go take the AP exam. And that's kind of embarrassing to get or when you go to college, whatever. It's really hard. I'm sorry, I was talking about the AP exam. It's really embarrassing when you know what you're doing and you forget something from the beginning of calculus, because I promise this is going to seem like nothing by the time we get to March. F prime of 3, F prime of 4 is 8. See how they tricked you? They've got F prime of 3 up there. They're just trying to make sure you're paying attention to details. So actually h prime of 3 is negative 40. The homework listed is not your homework. Okay. Next up, you need to take a disco break. I want you to go walk around the block, do something either outdoors or physical. Give your brain a break before we get here, before you push play again. And press pause. Do something. Play with a dog. Torture your cat. Whatever. I like to torture my cat. I'm sorry. Not really. I like to pick her up when she doesn't want to be picked up. That's as bad as it gets around here. Okay, so here we go. Okay, so here we have the first derivative. It asks for the second derivative. So all you're going to do is take the derivative of the first derivative. In order to make your life easier, you might want to simplify that derivative. If you like having a complicated life, you can go ahead and leave it the way it was. But I think most of us right now are kind of tired of having a complicated life. So let's go ahead and find the second derivative. And we get 48x. What happens there? We've got product rule and chain rule. Dun, dun, dun. I'm going to go ahead and restart just to make it easier to see and take the derivative of the first times the second and bring down the regular of the second. Don't accidentally, it's really easy to accidentally bring down the derivative of both pieces. And when you're in the middle of doing chain rule, forget product rule. And here, we're going to bring down the regular of the first. So there's the first. Bring down our power. Bring down our power. Subtract 1 from that power. Then, boop, 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 boop. We're going to take the derivative of the inner function. There's your inner function. The derivative of that would just be 2x. I think I should write out the steps over there. Give me a second to do that for you. You know what? That's not going to do you any good. The steps are going to vary depending on the problem. So, yeah, I tried to be nice there, but now I need to be mean. So, that's our second derivative, and we're going to simplify it a bit. So I noticed as I was doing that I had some things in common. I noticed that I had a 24 in both pieces. So I'm going to mess with that a little bit and see if I can do anything with it. For that reason, I did not multiply in that 4. And also notice that they both have an x squared minus 5 in common. I'm going to try to factor out a 24 and an x squared minus 5. And lo and behold, it factors quite nicely. And we end up with 24 times x squared minus 5 times 5x squared minus 5. Very pretty problem. Okay, if you have a TI-89, I can't help you. So read the directions and see if you can figure it out. We're going to figure out where f has a horizontal tangent. Well, f has a horizontal tangent when your first derivative is 0. Okay, so the I change it using product rule from a quotient to a product. You could use quotient rule. There's no issue there. The derivative of the first would be the derivative of x goes away, and then you bring down the regular of the second, then the first times the derivative of the second. Now the derivative of the second is where it gets complicated. Take down the power, subtract 1 from the power, and then you need to remember to use chain rule, because you need to take the derivative of that inner function. Okay, now we're going to talk about some factoring that you have never learned. And I think the first year I taught calculus, it occurred to me that y'all had never seen this. And the second year I taught calculus, this kiddo, who is now probably 30, getting his PhD in mathematics, put together a very quick worksheet on how to factor these suckers. See, we've got this power and that power, and you have done very little factoring with powers that look like that. But the lowest power involved is -3/2. So we're going to factor out 2x minus 1 to the -3/2. So here's where it gets janky. Look at that stinker. Think about what it would mean to factor out a 2x minus 1 to the -3/2. Otherwise said, what do you need to add to -3/2 to get -1/2? you have to add 1. So we actually have right there, right here, 2x minus 1 to the 1. Our second term would be x, let me underline it just in case, x, that's not very good underline, is it? X times negative 1/2 times 2. This whole thing goes away because we pulled out a negative 3/2. Okay. X times negative 1/2 times positive 2 would just be negative x. Oh, I'm tired, you guys. The things I sacrifice for you. It's only like 8:30. Okay. No, I'm exaggerating a little bit. It's 9. I'm not exaggerating much. Now, did you answer your question? No, you did not. Now you need to set that silly little stinker equal to 0. You're going to set the first bit equal to y1, the second bit equal to y2, and you're going to find that those two, writing the wrong thing, that this is only true when x equals 1. You could also think about it the way that I did before I graphed it, and I said, the top of this fraction is x minus 1. When will the top be 0? The top will be 0 when x is 1. Does it matter what the bottom is? No, it does not, because you can't have a bottom equal to 0. Okay. We're going to find g prime of x, given that g of x equals f of 2x cubed. That means, don't overthink it, g prime of x equals f prime of 2x cubed all times 6x squared. That is all the answer you can give. You don't have enough information to give any more of an answer. Next up. Okay. Whoa, that is a funky little line, isn't it? Right there. All that zigger-zaggerly stuff going on. I don't even know how that happens. It looks like somebody took some sort of digital crayon in there. Anyway, pixelated. Use the graphs of f and g to find the following if they exist. H of x equals f of x times g of x, and we're going to find h prime of 1. In order to do this, you need to find it in general terms first, just like you should have on the test. And now you're going to plug in 1, and f prime of 1, the slope of f at 1 is 2, g of 1 is 3, f of 1 is 3, and the slope of g at 1 is negative 1. So you get 3 for your answer. Okay, you're going to need to be able to see that previous. You're going to have to pop back and forth between slides, so I'm probably going to do that. I guess you might have it on paper. If you don't have it on paper, I'm sorry. I personally am not printing at all. I haven't printed for years. Okay, here we go. Next slide. Dun, dun, dun. Okay, prime of x. We're going to use the quotient rule. We're going to find it in general first. Then we're going to plug in 6. Then we're going to find our values. Then we're going to find our answer. Okay. Everything looks so Oh, 60. Haha. That sounded really silly. Okay, so we look at our graph and g of 6, 1, 2, 3, 4, 5, 6 is 4. So we're going to replace that with 4. F prime of 6, the slope of, oh, y'all, that was F. G of 6 is 2. No. Okay, 2 and F prime of 6. So the slope of F at 6 would be -1/2. And F of 6, what did I say that was? I said that was 4. Almost wrote 6. And G prime of 6, G prime of 6 is, the slope of G is -2. -2. And again, G of 6 was 2. So we've got -2. Oh, not -2. -1 plus 8 is 7. All divided by 4. Now we're going to find P prime of 6. Before we find P prime of 6, we're going to find P prime of X in general terms. Once we've done that, we go ahead and replace X with 6. And we go back to our graph to figure out what G of 6 is. And G of 6 is 2. So in our next step, which we're not ready for, we're going to figure out what F prime of 2 is. Right now we need to figure out what G prime of 6 is. So what's the slope of G at 6? The slope of G at 6 is -2. Sorry guys. And F prime of 2? Look at F prime of 2. F prime of 2, oops. F prime of 2 is right there. It's a corner. It's undefined. So, when we go in there, we have to say that this whole thing is undefined. It doesn't matter that we almost got it done. It's a bummer. But the whole entire thing, I mean, it's a bummer that we did all that work. And it turns out to be undefined. Okay, next up. T of X, last one. G of F of X. We're going to find T prime of 7. So we need to find it in general terms first. We need to find T prime of X. Okay. So we take the derivative of the outer function, keep the inner function, times the derivative of the inner function. And we're going to replace X with 7. And F at 7. 1, 2, 3, 4, 5, 6, 7 would be right around, oh, I cannot draw these circles, can I? That would be about 3.5. We're going to say it's 3.5. And F prime of 7 would still be -1/2. Show you on the graph real quick. Boop, boop. That slope is still -1/2. Okay, G prime of 3.5. Oh gosh. 3.5 goes straight up. Oh, that's a much easier number than I expected. It would just be 3. Right? G, 3. Okay, yep. Oh, it's G prime of 3.5, not G of 3.5. G prime of 3.5, that's a slope of 1/3. So we've got 1/3 times negative 1/2. Was that a slope of 1/3? That's a slope of 2/3. I'm tired. Y'all, you don't even want to know. Why am I so tired? 2/3 times negative 1/2 equals negative 1/3. There's the slope of t. And the homework below is not your homework. Y'all have a fabulous, fabulous evening/day. Take care. Bye-bye.